Hello, welcome to the Excited Education channel. I would like to request each and everybody who is watching this video first make subscribe, comment, share and like in order to get more as soon as possible. So this channel is concerning about biology and mathematics. Now we are going to discuss about mathematics on the point called the integral test. You are highly welcome.
Morning class, how are you? I think you are so fine and also me I'm fine. I'm teacher Amy as usual from Excited Education channel on YouTube. Just follow me by subscribe, comment and share in order that to heard about mathematics and different modules about biology. Now we are going to discuss about mathematics and we are going to discuss on point called the integral test. So we are going to discuss about what is integral test in part of sequence and series, and we will just use different ways in order to understand how can use integrals to work out the sequence. So what we call it integral test. Let us go ahead. As I said, we are going to discuss about the integral test. In integral test, you have to find that whether the function is positive way, is in positive part or is in negative part, or whether it is increasing or decreasing, whether it is discontinuous or continuous. So here we have to think about, before you react on the integral test, you have to think about increasing point, increasing or decreasing of function. Yes, we have to think about positive and negative function. We have to think about continuous and discontinuous. So we have to think about these three things. Determine whether the function is increasing or decreasing, determine whether the positive function or is a negative function, determine whether it is continuous and discontinuous. Here we are going to use this in terms of sequence. In terms of sequence, where we find that the epsilon of infinite n, which is equal to 1 of f of an, where an is our series or our sequence, if and only if the 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 improper integral, the improper integral of the function is equal to a will be expressed in terms of f of n. And here we are going to use this system of sequence in terms of f of n, and where f of n can express in terms of x or in y or in any letter, and then we work out how we find tests, integral tests of the sequence series. We have two rules we have to obey in order to solve out the integral test. Here, the first rule, two rules. The first rule we have to think about the integral of the integral of infinite of 1 of dx is convergent. Is convergent in other words, by using the integral test in sequence and series, we are going to first tackle on the convergence and divergence of the function. Then by using the integral test, before you think about the convergence, you will say that the integral of infinite to 1 dx is said to be convergent if and only if the integral of infinite 1 dx will be convergence if the integral, if and only if this summation of infinite n which is equal to 1 of an is convergence, and will be divergent if divergent if and only if the epsilon of infinite of n which is equal to 1 of n is also divergent. So, dear students, these are two rules you have to think about the integral test. If you compute about the summation of infinite n is equal to 1 over n and you find that it is convergent, then conclude that the integral of dx of the an will be also the convergent. And if we compute about the integral of the summation of infinite of n which is equal to 1 of an and we find that it is divergence, then conclude that the integral of an in terms of f of x or f of n is also called the divergence. This is the two rules that you have to govern before you react on about the integral test in the sequence and the series. So we are going to use these two rules that we have provided here in order to solve out the integral test of the sequence and the series. So dear students, let us talk on the example of one of the example of the integral test. Question number 1. We have the summation of infinite of n which is equal to 1 of 1 over n plus 2 then squared. We are going to use this example to compute about the convergence and whether the function is convergence or is divergence by using integral test. By using integral test. So here, as I said in the introduction, you have to think about whether the function is continuous, whether the function is discontinuous, whether the function is increasing or the function is decreasing, or whether it is positive in positive part or it is in negative part. So here, as I said also in the introduction, I said if you have the an as the function which is equal to 1 over n plus 2 squared, you have to express it in terms of function, and you get that in terms of function will be equal to f of x which is equal to 1 over x plus 2 then squared. This in terms of function. Before you compute this function, you have to express it in terms of function. And then after, you will compute about the first derivative of this function. And this will be also converted by this formula 1 times x plus 2 per negative 2. By the way, it's the same. If it is in the denominator, you put it on auto in the numerator. This 2 will take the sign of negative and stated in this form. So here, let us go ahead. In integral test, first you have to think about the derivative. So before you go on, you have to make the derivative of the function that you have given. And the first derivative of f of x will be equal to 1 x plus 2 per negative 2. Then you compute the first derivative. So here, I think that everybody have learned about ways and different methods that can be used to compute the part of the derivative which have power. So here you will find that this will be equal to if you have 1 times x plus 2, we take this as a function, and here it is a function minus 2. Then you know in product form we will find that take one derivative, yes, times x plus 2 power minus 2 not derivative, then plus 1 not derivative times x plus 2 power minus 2, which is the derivative. Then as you see here, this will be equal to derivative of 1 will be equal to 0. 0 times this one, this will be equal to 0. Then plus this one, x plus 2 power minus 2, then in general derivative. This will be equal to minus 2. Yes, this will be equal to minus 2 times x plus 2 power minus 3. Yes, as you see here, we take minus 1 in derivative. Then this can be expressed in terms of 2 minus 2 over x plus 2 power 3. This is our first derivative of f of x. After computing the first derivative of the function, then you have to take this function and use it in steps of integral test for this function to determine whether the function, this sequence is divergent or is it convergent. In order to express this, you have to mention, as I said in introduction, is this function in negative or is in positive. So, and you find the range of that function where you can integrate it in that range. So after this, you have to think about that. For instance, you can use a graph or you can use a number line. Right? Now let us use this number line. If you have, for instance, this is the x-axis of the function, then you will use this function by computing the variation table of it and plot it on the graph, and you find that if its curve curves up or in the part of positive, we say that the function is a positive function, and you compute the range and the domain where the function goes out in the negative part, and you say this is the part of the negative form of the function. So here we find that if we use the intervals in a number in order to compute the intervals, you find here it will be, if it is here negative 2 and it is here negative infinite and positive infinite, and this will compute that the function here in this side will be negative and this side will be positive. By using the graph, we will find this form. And in our question, in order to compute this, you have to know the interval that question is on the negative or is on the positive function, and that interval, whether in negative or whether in positive, is the one that we use while we are computing the integral of the function. So here we will find that the function will have from negative 2 to negative infinite. This is where the curve will be, and the interval we will use, it is negative 2 and negative infinite. Positive, yes, positive infinite. So here we are going to use this interval in order to integrate the function we have, and we will integrate the function but not the derivative. So here we put the integral of this infinite negative 2 of the function you have. This is f of x, then d of x. This will be equal to integral of infinite of minus 2, then f of x we have, it is this one, 1 over x plus 2, then squared, then x. So here to integrate this, I think we have noted much about this. We are going to use the integration by part where you have to rate and then compute it, the data you rate, and then you find it, you replace it on its value. Here we rate, we say that let v be equal to x plus 2. Then dv will be equal to dx. So in integration by parts, you rate as this one be a whole. If it is this a function, you just rate it as a value and then compute its derivative, then follow the steps in order to integrate this. Then after this, we will find that the integral of 1 over v squared. This is v, and then v squared is of d of dx. Here, the integral of this one will be equal to the same integral of, here it is infinite and negative 2, infinite and negative 2 of v power minus 2 dx, and this will be equal to v minus over minus 1 plus c, and then replace your value in the function in order to get the point that you have. This will be equal to the same writing minus 1 over v, and this will become 1 minus 1 over x plus 2. This is as a function. So even you can write it here plus c or not, as where the c is constant. After this, you will take the limit. Okay, move on this side. Then compute the limit of b approaches to infinite of f of x that you make the derivative. This will be equal to limit of b approaches to infinite of minus 1 over x plus 2. We'll find it on b and b negative 10 and 1. So here, this will be equal to limit of b approaches to infinite of minus 1 over x plus 2, which will be equal to limit of b approaches infinite minus 1 over b plus 2, and this will be equal to this part. We find that it will be equal to 0, and then minus 1 over 3. This will be remaining this part, and minus times minus, this will be equal to positive. Then limit of b approaches to infinite of minus 1 over x plus 2 will be equal to 1 over 3. This is our function, the general solution of this one. And we find that in integral test and to define the divergence and convergence of the function, if you compute the limit of the appropriate an and you find the real result, this will conclude that the function is said to be convergence. If we find that it is not equal to 0 and it is not equal to a certain number, maybe it can be the infinite, then you conclude by saying that the an or the sequence is said to be divergent. And we find that if this is equal to 1, therefore n which is equal to 1 over n plus 2 squared is convergence. So I think this is about the integral testing of the sequence and the series to determine whether the function will be convergent or divergent by using integral test. And this is our lesson of today. Thank you for attending this and watching this. Remember to make subscribe, comment, share, then in order to follow up different things that you have. So I think we can see you the next session. Thank you.
Thank you for watching my video. I would like to request also to make subscribe, comment, share and like, and see you in next class. May God bless you all.